All right, so I want to do a little bit of a harder problem in which we calculate the change in energy for a reaction using bond energies. So in this example, we're going to calculate delta E for this reaction. So I've drawn some pretty complicated molecules here. Each line that I've drawn represents a bond. So 2 electrons that are shared. And in some of the molecules, the bonds are not drawn explicitly, and you're going to find this in the examples that you do for this part of the chapter. So the general strategy for these questions is you have to tally up the bonds that are broken and the bonds that are formed, and then look up their bond energies in the table and plug them into the delta E equation, where you subtract the sum of the bond energies of the products from the sum of the bond energies of the reactants. So a few things to notice. Sometimes the bonds are not drawn explicitly, like 2F2 means that we have 2 molecules where the F's are bonded to each other. Same with the HF. Here we have 4 HF molecules. So if I'm tallying up the bonds broken and formed, it may help to kind of draw out some of the bonds explicitly. So for my tally, I'm going to make a few columns. Bonds that are broken on the left side. Well, it looks like we're going to be pretty much breaking every bond here, right? This, and this are all getting broken, right? We don't have any more NH bonds. So it looks to me like we have NH being broken 4 times. Now, what you have to do is look up the bond energies in the table, and you're going to take that 4 and multiply it by the bond energy from the table. So that's 391 kilojoules. So let's do that for each of the other bonds. Now, we're going to break the nitrogen-nitrogen single bond. There's only one of those. And looking up its bond energy in the table in your book, it's 160 kilojoules. Finally, it looks like we are going to be breaking both of these fluorine bonds in the reactants here. So I am going to put FF here as well and say that I am breaking 2 of those bonds and looking up that bond energy for the FF bond in the table. It's 154 kilojoules. So that takes care of the bonds broken on the reactant side. Now, let's look at the bonds formed to make the products. So let's do a similar kind of tally where we're looking at the bonds formed for each of the products, and then we'll also look up their bond energies and tally their bond energies. So we are forming a nitrogen-nitrogen triple bond and 4 HF bonds. So I'm going to list those here. My nitrogen-nitrogen triple bond I'm going to make one of those in this balanced reaction, and I have 941 kilojoules. The HF bond, I am going to form 4 of those, and if I look up its bond energy in the table, it's 565 kilojoules. So now, when I calculate the delta E for the reaction, I want to take the sum of the bond energies of the reactants, so all of the bonds broken, and subtract the sum of the bond energies of the products. That is to say, all of the bonds formed. So I'm going to make a big tally here. That 4 times 391 kilojoules is going to be added to 160 kilojoules, because that's just multiplied by 1, plus 2 times 154 kilojoules, and that takes care of the sum of the bond energy of the reactants. Now I'm going to subtract from that the sum of the bond energies of the products, and there I just have 941 kilojoules because there's only one nitrogen-nitrogen triple bond, plus 4 times 565 kilojoules. So you can do all of that arithmetic in your calculator, and you should come out with minus 1169 kilojoules. So this would be the change in energy associated with that reaction. Now, sometimes you might be given an example where not all of the bonds break. And if a bond stays intact going from left to right, then you can just leave it out of the analysis. You don't have to consider it. But in this example, every single bond was broken and all new bonds formed to make the products.